coefficient. Like everything so far, there are two different things to look at: the population and the sample. As you know, they always have different notations. The population correlation coefficient is a Greek letter, rho. The correlation coefficient for a sample is lowercase r. I'm going to talk about r, like it's the same thing for rho, but r can be a number anywhere between -1 and 1. If r equals plus or minus 1, it's a strong correlation between the two variables, either positive or negative, doesn't matter. Strong positive or strong negative. If r is close to 0, that implies no relation, no correlation between the two variables. So what about r equals 0.65? Yeah, that's good, right? It's not close to 1, but it's not close to 0 either. So it's quite a strong or medium upper medium correlation between the two variables. So now let me share my screen again, and let's determine the correlation coefficient for what we see here. So go to stats. Okay, let me see if I can determine in any other way. I guess not. Okay. So I have regression. We choose regression. I may be able to, I don't want to jump. Okay, that's what I meant. Okay, so summary statistics and correlation. We're going to use the regression in a minute, but I don't want to jump ahead. Okay, correlation right here. So time and depth, of course, both have to be highlighted. And we want to say period, that's not what I want. Duplicate or no, correlation of a column with itself, no. Okay, so just compute. Here it is. So StatCrunch already computed the correlation coefficient for us, and that is a sample. So the notation is r, lowercase r, equals 0.77282153, which is definitely a positive, quite strong correlation.
So what if the correlation is like -2 or 2?
Can it only be like positive correlation?
Yeah, can it only be between -1 and 1?
Absolutely. Okay. It has no measurement unit. Yep. And something very important, is not resistant. Can anyone give us an example of another non-resistant statistic?
Median.
Non-resistant.
It's the mean.
Mean.
Standard deviation.
Mean is not resistant. So what does that mean? So if I have this scatter plot, and all of a sudden I get this value, that will change the correlation coefficient drastically, like the mean. If I want to calculate the mean of a data set and all of a sudden I have something out of the ordinary, if you want an outlier, the mean will be pulled because now the whole distribution becomes skewed. The same thing with R. R is not resistant. Good. Any questions so far?
Nope, I'm good.
Okay, perfect. We have a table that I was trying to locate. I'm trying to locate a table 2. I'm going to share my screen. It's an important table. I just didn't get a chance to find it. Gee, guys, you're always in the way. I'm kidding. So let me see if I can go to the e-text for a link. I want, yes, I want this. Let's see if I can get table 2, because I want to post it for you so we have it handy for the midterm. Draw, where is my table 2? So you won't let me move on if I don't do something here? Oh, I can click on the, okay, scatter diagram. Okay. If you find table 2 for me, don't torture me. Tell me where it is. I want table 2. Okay, I can find table 2. I have to do more digging. Table 2 that I'm looking for gives us a diagnostic on the linear regression. But I can't find table 2. So I will leave that alone for a moment or two, and I will dig it up. But I need a little bit more time. Okay, so for that reason, let's go to 4.1, and let's select whatever you want. 4.1, this is it, about 4.1. We are ready. Okay, you choose. A 17 question. Which one?
9.
9 it is. So let's start with 9. Okay. Match the linear correlation. Very good pick. Coefficient to the scatter diagram. First of all, it's negative. So first of all, I should say second of all, this has no correlation, no association. These two variables are not associated because the scatter diagram does not show any linear pattern. This one has a linear pattern, but it's not negative. So these two are completely excluded. This one is absolutely perfect, -1. So this is a correlation coefficient, a negative correlation, extremely perfect. I've never seen this, right? Everything is in a perfect linear relationship and a negative slope. So this is -1. So this is the only option. So this is sort of a negative slope and not -1 and not very, very small either, towards 0, I mean. So this is it. Does everyone agree with this?
Yes.
Good. Anything else?
Question 11.
Let's look at 11. Okay, in which scatter plot is R -0.7? So again, these have to be excluded. This is positive, this is nothing, this is positive. So we're looking at these three. This is again perfect. There is no such thing, almost never. This and this. So these are the only options for negative 0.7. Now, this appears to me to be less steep than this one. This is steeper. The reason why I'm drawing imaginary straight lines is because we're going to talk, the next step is linear regression. So I'm trying to fit a line. Of course, there is no way I can pass through all these points, but I'm trying to fit a line here. So this is definitely steeper than this. So I would say that this is closer to a negative 0.7 than this. I would consider it A. Where's my keyboard? Okay. I know. I know what it says, but I think that this is steeper than this. But if it's not, if they don't consider A, then it must be D. Because this is perfect and the other ones have nothing to say about, I mean, and have no connection to R equals negative 0.7. So to me, this is steeper, but I guess they consider it because the points are closer. But I am not in complete agreement with D. I think A is more has more of a steeper slope than this, which is closer to horizontal than this one is. But they consider D, but I disagree completely. So if you encounter situations like this, let me know, because I am compiling a set of questions that I think are either non-relevant or, like that one, I informed the coordinator of the course, the one that asked to make decisions with 4 entries or 5 entries.
Excuse me.
Yes.
But wouldn't it? I guess it would kind of be the D one because -7 is closer to being a -1, which would be a more stronger correlation. And the first one you had picked was more of like more scattered points, less of a correlation than the second one. So, like, because it's -7, it's closer to a 1 than a 0, which would be like that stronger correlation that was like visible in the scatter plot.
So let me just very good point. So let me explain the way I looked at that graph. Very good point. So one graph looks kind of like this, and the other one looks kind of like this, right?
Yeah.
Okay, so see this slope and this slope, this is closer to 0 than this one is. This is steeper. So this would be maybe minus 0.4. This should be negative 0.7.
Okay.
It's about, both of them are correlated, but this one is steeper, which is closer to -1 than this one is.
Okay, so it's more so about how steep it
Yeah.
is as opposed to
Yes.
how
So
clustered the points are.
yes, because we are talking about, although the correlation coefficient is not the slope. I agree with what you're saying. The correlation coefficient is not the slope.
Okay.
But to me, this is steeper than this. If we want to talk about how close they are, as points in the scatter diagram, I would have to agree with you that these are closer together than these ones.
So correlation coefficient is not a line of best fit type
No,
situation?
no. Very good point. So the line of best fit, called the linear, that's the next step, regression line. So yes, I don't want to confuse you. The fact that I drew the linear regression line through these, but to me this was less steep than this.
Okay.
But you can say that they are closer than this. These are more scattered. Because they are more scattered, then I would consider this the better choice.
All right.
And the line,
Thank you.
You are correct. I would have to agree. And the linear regression line is what is called y hat. So that's a predicted y value. And it will be a line. So let me write it here and then I will go back. So then y hat equals, it has a slope times x and then plus a y-intercept. So this is what we call the line of best fit. And this is what I drew here. Good. Very good point. Thank you.
Can you stay on that paper for a second?
Yes,
Sorry.
of course. Of
I'm
course.
still writing that down.
Oh yeah, we're going to write this again.
Oh, okay.
This is in 4.2. I just jumped ahead a little bit, but I'm going to write it
Okay.
again.
All right, never mind that.
Yes. So we're going to talk about this, and that's the next step. I wanted to find that table too, but I couldn't find it. So.
The question I would like to look at.
Which one?
16.
16. Very good. Let's take a look. So listed below are the ages of female and male winners of a certain award in 15 selected years. Each pair of ages is for the same year. Construct a scatter plot. Choose the correct answer below. And I know you would like to put this in the graphing calculator, which you can. It's fine. But StatCrunch is so convenient. So we want to say it again.
Can you show us how to do it on the calculator after you do a StatCrunch one?
Absolutely. But can I just show with the first 5 ordered pairs and not the whole thing?
Yeah, that's fine.
Okay, absolutely. Let me copy. We have 31, 33, 37, 28, 32, just with the first 5. 38, 45, 30, 42, and 37. Okay. Good. So let me just do this first so I don't forget. Where is my calculator? I had it ready here. Yep. So we go to Stats. We want to edit. And go up, highlight L1 and clear. Clear, enter. The whole thing disappears. And then I'm entering 31, 33, 37. Of course, it's not going to look the same because I cut it short. And 32. And enter. And we go to this y variable, 38. And then 45. And then 30. And then 42. And last one, 37. Get out of there with second and quit. And now up here above y equals, there is what it's called stat plot, second stat plot. So as you see, they're all off. So I'm going to choose number 1. I'm going to turn it on by pressing enter. Now don't get scared if you do this and then you